All right, 4.1, basic trig graphs. We're going to talk a little bit about the various setups of, we'll start with your three basic trig functions, sine, cosine, and tangent, and some of the details involved with their graphs. First, start with domain. Domain for sine and cosine are both all real numbers. So negative infinity to infinity, negative infinity to infinity. Tangent, we're going to write this a little differently, okay? It's going to be all reals except all reals. Now, think about when tangent is undefined. It's whenever cosine is 0, right? Because tangent sine over cosine. So it's all reals when x is not pi over 2 plus k pi for all integers k. For all integers k. Okay? Meaning every pi over 2, because that's whenever pi over 2, 3 pi over 2, every time we hit those two values on your unit circle, it's going to be undefined because your denominator is 0. Next, let's talk about range. With sine and cosine, it can only be between negative 1 and 1. So negative 1 to 1, including negative 1 and 1. And for tangent, it's going to be all reals. It's going to hit every y value if it wanted to. As we showed you the graphs before, there are lines that, kind of squiggly lines that keep going up forever. Next, amplitude. Amplitude is really only defined in sine and cosine. And in the original graph, they're both 1. Okay, just in the original. And for tangent, not defined. Amplitude is half of the length of the wave. In the original graph, it's 1. Because it goes from negative 1 to 1, which is a distance of 2. Next, we've got period. Period for sine and cosine is 2 pi. And for tangent is pi. The distance in between the asymptotes rather, is always going to be pi. Zeros. The zeros in these cases are, for sine, it's every time we hit pi, right? So it's when x is equal to k pi for all integers k. And then for cosine for every pi after pi over 2, that is going to be what makes cosine 0. For tangent, tangent's going to be the same as the y values, right? Because remember, sine, it's tangent sine over cosine. So for this case, it's going to be just the same as sine. X equals k pi. Now for one little other thing, asymptotes. Asymptotes, we don't have asymptotes for sine and cosine. That's why I didn't really put a box underneath this, because it's only going to be for the other 4 trig functions. So tangent will be x is equal to whenever you can have asymptotes whenever cosine is equal to 0. So it'd be x equals pi over 2 plus k pi. Now the other 3 trig functions, cosecant, secant, and cotangent. Domain. So domain for cosecant, remember cosecant is 1 over sine, right? So its values that make sine 0 are not going to be part of your domain. So it's going to be all reals when x is not k pi. And for secant, when x is not 0. So it'd be all reals when x is not equal to pi over 2 plus k pi. Cotangent, it's whenever sine it can't be 0. So same as cosecant. All reals when x is not k pi. Now the range for cotangent is the easiest one. Negative infinity to infinity, same as tangent, those graphs shoot up. The range for the other ones, on the other hand, though, rewritten as this. Okay, so if you remember, it's kind of the opposite of what the range was for sine and cosine, right? Because sine and cosine was between -1 and 1. Now it includes -1 and 1, but it's everything from 1 to infinity and -1 to -infinity. No, amplitude's undefined for all these. So I'm just going to put a line through it. If you want to write something down, it's not defined. There's no amplitude with any of these three. Period for all of these. Period for secant and cosecant is 2 pi, just like their reciprocals, and then pi for cotangent. Zeros. The zeros for cosecant, there are none. It never hits the x-axis, and same with secant. For cotangent, on the other hand, remember, it's whenever cosine is 0. So therefore, I'm just going to go like this and say it's the same as that. So it's going to be pi over 2 plus k pi. Asymptotes. For cotangent, it's whenever cosine is equal to 0. So it's x equals k pi, which is the same for cosecant. X equals k pi. And then for secant, it would be x equals, not pi equals, x equals pi over 2 plus k pi. So we're going to find all of the values from 0 to 2 pi that make this true. So think about tangent, remember it's sine over cosine, right? So values that make sine 0 will also make this 0. So for the solutions here, sine is 0, we're at 0, pi, and 2 pi. Those are your three values that make the output 0. So you might have seen this before in your algebra days, but an even function is whenever we put negative x everywhere into a function and we get, well, what it was originally, as opposed to an odd function, we put negative x everywhere and we get its opposite. Odd functions are symmetric over the origin, and even functions are symmetric about the y-axis. If we think about the graphs of these functions, the even functions are reflect over the y-axis at y equals cosine x and y equals secant x. Those, if you look at those graphs, those are the ones that reflect over the y, and the origin are the other ones. Y equals sine x, y equals tan x, y equals cotangent x, and y equals secant. Not secant, cosecant x. So let's prove that the secant function is even. Okay? So if we're going to try to prove secant theta is even, that means we're putting in negative theta everywhere we see it. And therefore, when we do that, secant's reciprocal is 1 over cosine. And we know that cosine's an even function. So therefore, negative theta is going to get us 1 over cosine. And therefore, we are back to secant. Now, another reason why that's true, let's think about this. Think about unit circle, right? Let's say I had pi over 2, right? Pi over 2 is over, or not, let's not use pi over 2, pi over 4. Pi over 4 is right here, right? So if we're doing the opposite of this, right? So opposite theta, so that means we're going backwards, pi over 4, right? What happened? Our x value stayed the same, right? But our y value flipped. So that's why secant and cosine, if you flip the values, you're still going to get the same x value or same secant or cosine value because it just reflected over the x-axis, as opposed to the other 4 trig functions where you will be having to flip the whole sign. So prove this is true. sine of negative theta times cotangent of negative theta is equal to cosine theta. So we know that sine of negative theta is equal to what? Is it even or odd? We know that it is odd. So since we know it's odd, sine of negative theta is equal to what? It is equal to negative sine theta times cotangent negative theta is equal to what? We know it's going to be also odd, so it's going to be negative cotangent theta. We know cotangent theta is equal to cosine over sine. And two negatives multiplied together make it positive, and the signs cancel, leaving me with just cosine theta. We prove that identity. Okay, one more example. Sine of negative 3 pi over 4. Make our lives easier, and we can use our identities that we've been doing. So sine of negative theta, as we know, is negative sine theta, right? So I can move the negative up front, and we all know what sine of 3 pi over 4 is. It's root 2 over 2. So therefore, your answer would just be negative root 2 over 2. I appreciate you watching, and we'll see you in class.